What is the average height of two people? 150 centimeters and 170 centimeters tall. Again, we think average here, we're talking about arithmetic mean. Don't worry, we're not getting into that in this course, but the book just throws this average word around. That's what we're talking about. Okay, so I just talked about Dannon's marks. You knew you hit right in the middle. Well, anyone need to actually work this out in a math, or do you know what the average height would be of these two people? 160. How'd you get that? You went 150 and you went 170 divided by 2, right? You did all that in your head. No, you just took the middle point. If you see what the middle is, it's 160. Yeah, you know that because you understand what this word means. If I do that, that's 320 over 2, which is, as promised, 160 centimeters. Okay, so far so good. What if I'm talking speed here? Okay, you all know that. I know that. That isn't real physics notes. But let's come to terms with what this word actually means. What is the average speed if you travel at 10 kilometers an hour for 1 hour and then 20 kilometers an hour for 2 hours? Any guesses? So let's kind of maybe, I don't know, state the obvious. Is it 15? Good. It is not 15 kilometers per hour. You don't just cut it halfway in the middle there. No. You're guessing in the right direction. Okay, good, good. This is not really physics. This is kind of common sense, but a lot of people don't have it. Even adults, like people twice your age. If I'm traveling for a longer period of time at a greater rate of speed, then it's going to be skewed up a bit, right? I'm only going 1 hour at 10 kilometers an hour. I'm going 2 hours, twice as long at 20. So you know it's got to be greater than 15. Here's how we work it out. Okay, distance, average speed, this is an actual formula. It's on the back page of your book. Is total distance over total time. And you've seen this in science. You've seen this, I know it's in the Math 10 book. But how do I get the total distance? Do I need a formula to figure out if I go 10 kilometers an hour for 1 hour, how far did I go? Yeah, 10 kilometers. If I go 20 kilometers an hour for 2 hours, I went 20 kilometers, and then I went another 20 kilometers. So how much is that? You bet. Okay, so that we kind of can do in our head, because we already know this formula. What's my total time? Well, I traveled for 1 hour. I traveled for 2 hours. So that's 50 over 3, which is, whoop, that's not the one I want. It's more than 15. Is it 17 and a half? That's what someone had a guess as. Not quite. 16, let's round it, 16.7. Actually, to be technical, I got 2 sig figs here, so I can only have 2 sig figs here. 17, sure. So not quite 17 and a half, but that was a good guess. Okay, so I know it says average. There's a way to figure it out. And that maybe seems kind of simple, but you know what, guys? I've had some pretty smart kids get questions wrong that this formula is on the test because they forget this simple little point. Okay? So this is it in words. What is it in a formula? Average speed. You've seen that before. It doesn't have the words total there. Look on the back of your book. The formula's there, and it actually, I don't even think it's in that form. It says this. D is VT. Okay? That's what it says. There's no words there saying total time is speed, but you got to kind of know the relationship here. That's average speed. There's also another term you got to know, and it's different. There's more than one speed in the world. Instantaneous. What's the key word in instantaneous? Instant. That doesn't mean pudding or rice. It means, anyone want to guess? Average speed is total distance over total time. Instantaneous speed would be then speed at any given, what's the key word? Yeah. Now, if you get driving, which some of you guys are, does a cop care about that? You can average, if the speed limit's 90, you can average 85 over a trip from here to Alberta. That's the one he cares about. At any instant, if you're exceeding 90, they'll give you a little fudge factor. But if you're going 110, when he pulls that trigger on that radar, he doesn't care what your average speed is, does he? You're getting a ticket. So most of you figure out what that is. That's a speed at any given instant. Okay? Here I'd be safe if this was a speed zone in a school because I'm under 30 both ways. But like I said, it doesn't matter if you're doing less than 30 by the time you end the school zone. If you're doing more than 30 at the beginning, that's where they try to get you, right? Instantaneous speed's what matters. Okay? All right. This here, I assumed I went in the same direction. It didn't change. What if I'm not going in the same direction? Is speed a vector? No, it's not. Is there any direction here? There isn't. That is a scalar. Speed is a scalar. What is the vector of speed? It's velocity. That has magnitude and direction. Okay? If I care about direction, then I have to talk about velocity, not speed. Have we seen that formula before? What's the difference? Here's the difference. If I put a little vector sign over that v, now it's velocity, not speed. And some old books actually did use the word s instead of v. Okay? It essentially is the same thing. You just have to take one thing into account. This isn't distance now. That is displacement. Also called position is another word this book likes to use. So when I'm talking about position, I gave you a worksheet last time about vectors. Okay, it's not really how I got to that point where I finish. Okay, displacement is how far away am I from where I started. That's what I care about. The position. How does my position, how do you say that? How does my position change from start to finish? Okay, and we can use a Pythagoras to figure that out in a distance. If I know that distance, and I know that distance, then I can figure out the resultant. So how do I get my displacement? If I don't just go straight 10 kilometers an hour, and then straight 20 kilometers an hour, if my direction changes, then I just have a little more work to do to find out with the answer. Okay, this is actually delta D, so let's fix that, and that's delta T. And what's the back of our book say? That's what they have. They don't have the little arrows over it, but it does say delta. Delta means change, right? It's Greek letter D. You're going to get a lot of Greek letters before you leave this course. So that is change in displacement. As a little formula, it's just the final minus the initial. How do we write that? This is how your book writes it. Final minus initial. Other books doesn't like to write near the edge. Instead of an O, they have an I for initial. So if I get kind of, I don't know, if I start getting old and going back to how I used to write things and how other books write it, if you see DI, it means the same as DO, okay? It's the initial displacement. So, initial, there we go. Okay, that's changing. And you've done this in science, right? Maybe not with just displacement, but maybe with other things too. So, for example, what we had in math, we had this Cartesian coordinate, right? And we've done these questions. If I take O as my origin, we normally think of that as my starting point. But you don't always start off at the origin. If I started off here, and I finished off there, right? While we did this in grade 8, how far did I go? If I started here, and I finished there, graphically, if you have it, you're just going to count the units, right? 1, 2, 3, 4, 5, 6. I went 7 units, right? But in a formula, what is my displacement here? Whoop, final minus initial. What is my initial point? As far as this is concerned, that is -3, right? For x. We take left as negative. We take right as positive. So does the book when we're talking about physics. If we go right, we assume that's positive, because that's how our Cartesian coordinate existed. So final here is 1, 2, 3, 4 plus. Well, let's put that in my formula. What is my total displacement? Final is 4 minus initial is -3. And what does that equal? That's 7 units. We already knew that, right? Okay, now that's a vector. So I need direction, 7 units right. And right we took as positive, so that's why it's a +7. Okay, so that is displacement. Here it matters what direction I am taking. Okay, couple of graphs. If this is a displacement or position time graph, and let's say I start here at 0 for displacement, I might not always. Maybe I'll start, okay, I don't know, 10 kilometers away. But let's say I started there at 0. Time is, let me explain that. When I say delta t, we usually don't try to trick you. There isn't much sense in negative time. So when we say change in time, we're not going to give you something like a -3. Change in time means from 0 to 8 seconds, it's 8 seconds. We typically start at time 0. So change final, 8 seconds, minus initial, 0. You don't have to minus the 0. It's just 8 seconds. Okay? But if that looks like my graph, what's going on here? As a scenario, let's say 0 was my driveway. I started from my driveway. I moved some distance away from my driveway. So if I take that as 0 and I go away from it, I'm going to say that that's going to be positive. And you guys remember from Math 10? When I'm talking about slope of this line, if it goes up as we go to the right, is that a positive slope? Yes. And I've said it, and again, it should be in Science 10. What is the slope of a position time graph? Or displacement time graph? That is a speed. This is something you got to know. It's an easy mark if you do. And if you don't, well, it may be 5 marks on the test. Okay? So slope of displacement or position, time graph, is our definition for, well, I'll call it speed, but if we got direction, then it's velocity. Was this a question in your practice before the test? SI unit for distance, meters. SI unit for time, seconds. What is rise over run? Isn't that our definition for slope? Just look at the units. Meters divided by seconds. Is that a speed? Sure is. Okay? So that would be, in this case, positive. What happens if I have a graph that looks like this? Well, remember from Math 10, a line that looks like that was a slope positive or negative? That's negative slope, so that would be a negative speed. Okay? Think of this as if I took 0 as my driveway. In this one, I drove from my driveway or rode my bike, I walked, whatever. Maybe I got to school over here. Maybe that was 5 kilometers away. Now, I'm starting at school, which was 5 kilometers, and I'm going back to position 0, which is my driveway again. I'm going the opposite direction. If I took this as positive, then that has to be negative, because I'm going the opposite way. And again, just think Math 10. That's negative, okay? Because that's a negative slope. I told you to memorize that in Math 10. What does this mean? Is that a horizontal line? What's the slope of a horizontal line? 0. What's my speed here? Remember, the slope of a dt graph is always your speed or your velocity. Here it's 0. Let's think of this common sense. As time goes on, I don't care if this is seconds, hours, days, that's my position from my driveway. Let's say I am 2 kilometers away. How does that change as time goes on? Here, how far away am I? Still at 2 kilometers. Okay, over here, how far am I away? Still 2 kilometers away. I'm not moving. What's another way to say I'm not moving? I'm stationary. My speed is 0. Okay? Kind of makes sense? Should. Just got to think about it a bit. Okay? Did that. Couple of examples. It's nice if this formula, that's how it is on your book. Okay? Speed, velocity, just depends on the question, but it's the same formula. It's not always going to ask you for v given d and t. We have to solve this thing for d, we have to solve it for t. So I'll give you a couple examples on that. Now, I also told some of you guys, maybe all of you, I've met a few kids who like this triangle. Okay? That's a relationship between v, d, and t. If you're solving for v, it's d divided by t. That you're given on your formula sheet. So then you plug up this v, and it says d divided by t. What if you want to solve this for t? You plug up t, and t is d divided by v. Okay, and if you want to solve this for, what's the other one I didn't do? D? Okay, if I want to solve this for d, then that means v, they're both on the same line, so you multiply them. So if that works for you, fine. Okay, but you got to remember how to write this triangle. I prefer to teach it algebraically. So if I'm going to solve for d, for example, if you travel at 40 kilometers an hour, how far do you go in 1 second, 5 seconds. Do you all note that the units are different, Jeff? No, you don't, because you weren't even looking at the screen. So we got a conversion to do, don't we? Why did we teach you conversions last chapter? So that you can get more marks. Okay, but first I got to solve this thing for D. It's asking me how far. That means I need a distance. I have a speed. Okay, I have a time. I got to get distance. How do I solve this thing for distance? Well, you can use the triangle, or algebraically, I want D by itself. How do I get rid of T? If I multiply that by T, it cancels out. Whatever I do to one side of the equation, I have to do to the other. So D is TV, which is what we got here with this thing too. Okay? Just think of it in terms of units. Time is in seconds. Velocity is meters a second. If I multiply that, what unit do I get? Meters. Is that a distance? It has to work, right? But problem I have here is how far I go in 1 second. I don't know what this is. Okay, I want to convert that. So let's do that. What is kilometers per hour in seconds? I got to cancel out hours. Okay, and then I got to cancel. Let's go hours. If you know how many seconds are in an hour, great, but let's pretend we don't. I know that 1 hour is 60 minutes. This is now in kilometers per minute. Okay? And I know 1 minute is 60 seconds. So minutes cancels out. I'm now in kilometers per second. Good. That's the unit I want. Okay? I just got to use my equation here for this. So what does that give me? 40 times 1. I don't have to do it, but I got to divide by 60. Okay, times 1, divide by 60 again. So 40 kilometers an hour is, I still have 40 kilometers on the top, but now this is in seconds. What am I doing? 0.0 1. Let's just do a couple. Not meters, kilometers. Okay, 0.011 kilometers per second. Because I want this in seconds. That is my speed. My time is 1 second. Here's my formula. D is VT. That's V. Kilometers a second. That's T times 1 second. Notice the seconds cancel out. What unit do I have? Kilometers, which is a distance. That's what I want. What is that times 1? Well, it's just that. Now, if I want to make that to meters, I guess that would look a little nicer. Okay? In 1 kilometer, and you could have done that up here, sure. There's how many meters? Kilo means 10 to the 3, or 1,000 meters in a kilometer. Times that by, move the decimal 3 spots, that's 11 meters. Kind of seem reasonable? If you go 40 kilometers an hour, in 1 second, you move 11 meters, that's 11 meter sticks. Seem reasonable? I guess so. All right. Now once we have that, do I need to do all this again to get 5 seconds? Or do I just need to multiply that by 5? Yeah, that's what I would do. Okay, if that's 1 second, then if I multiply that by 5, I get 5 seconds, which is 55 meters. in terms of safety, just think about that. If it takes you 1 second, if you turn your head for 1 second, even at the slow speed, you've gone 11 meters, right? A lot can happen in 11 meters, right? So keep your eyes on the road. Okay, so that's solving for D. Let's just do one more. What haven't we solved for? T. Again, let's do some different conversions, because you got some questions in your book where you're going to have to convert. If you travel at 25 meters a second and went. English is an odd language. Does that mean distance or time? It could mean either, couldn't it? Now that's definitely a distance. You went 4K. How long? Does that assume it's time, or could that also be a distance? Could be either, couldn't it? How long did it take? Well, I've already told you we're solving for T here. Here's my formula. Okay, I got to solve this thing for T. So let's put T on both sides. T divided by T is gone. I got TV equals D. But I want T by itself. So how do I get rid of E? Divide it away. And here's my formula in terms of time. Okay? If you like the triangle thing, cover up T, that's D divided by V. This one's a little harder to figure out with units because I got meters divided by seconds. Trust me, it's seconds, okay? All right, how long did it take? Well, do you see a problem here with my units? I have meters a second and kilometers. If I just put those two numbers in as they are, if I go 4 divided by 25, I'm not going to get the right answer. I have to make the units the same. What's easier, making that kilometers a second or making this thing meters? Yeah, absolutely. And everybody knows how many meters are in 4 kilometers? Okay, and if you don't, quickly, you do the conversion. 1 kilometer is, there's 10 to the 3 meters in 1 kilometer. Times 4 times 10 to the 3, 4 times 1,000, that's 4,000 meters, okay? So now I got the same units. So T is D, 4,000 meters, over V, speed, and that will give me time in seconds. How many times does that go in there? About that many times. If I then asked you, put that in minutes, do you think you could do it? How would you do it? Because if that's what the question's asking you, cancel out seconds, put it in minutes. There's 60 seconds in 1 minute. That's now in minutes. You just divide by 60, right? If it said, what is it in hours? You divide by 60 again. Okay, they may ask that. Okay, so here's some questions. That's going to be it for questions for this week. So if you want to do them all today, tonight, that will leave you nothing to do for maybe tomorrow. But don't leave them all for tomorrow, there'll be too many. Okay, that's about it for this whole section 2.1. Maybe a little help for number 8, my brain likes to do 8b before 8a, so it's a little tricky. Think about doing a graph. Maybe you want to do it in that order first, okay? So when you get to it, let's start with 39, of course.